morning, everyone. Hello. I had to let the cue play out. I couldn't stop it there. Hello. Got a lot of folks here. Welcome. Yeah, so I've it's morning here. I've got my tea, Baymax mug, and which is the biggest mug I have, so I'm prepared. So welcome. This is a boot camp workshop thing. Something I've been wanting to do for a little bit. I put the original version of this I put together for GameSoundCon. Um, and yeah, I thought it could get some more exercise on the interwebs. For those of you who are unfamiliar with me, my name is Dan Reynolds. I'm currently working at Epic Games as a senior technical audio designer. I've been there for just about 9.5 years, and that includes throughout the development of. I was originally hired to help QA the audio engine back in 2016. The new audio engine, the new 10-year-old audio engine. And Yeah, and I've been with the company ever since, including throughout the development of MetaSounds. So yeah, and I'll tell you what, even I am still learning things, but that's just because I understand, and it's something that I think everyone should appreciate, which is that game development moves pretty fast. It's a technologically driven uh, discipline, and so there's just a lot to keep up with. And when I started at Epic, there was only one audio programmer, and now there's many audio programmers, and so the work velocity is very high now. So yeah, it's really awesome. It's very exciting, but it's also a lot to keep up with, and so I appreciate that. And I think that it's if you feel like you're having a hard time, or you're struggling, or you just feel it like it's daunting. I mean, be assured it is a lot. It's worthy acknowledgement, and just stick with it and be persistent, and you'll get through it. I'm trying this new format out. I don't know. We'll see what it's like. I tried some bells and whistles. I've got like a transition and everything. So it'll be fun. We've got a lot of folks in the chat here. I put it up here on the screen, so if the video goes, if I port it to some other area, then we can see everyone's comments. We got Tom. Sorry if I don't know everyone by their handles. We may have met in person. How's it going, Johnny, Katja, Dominic? Yeah, Dominic. I mentioned earlier. The stream should be recorded by YouTube. I will have a local copy if it gets lost. But yeah, so there will be at the very least it accessible by YouTube. Heinzenecht Willem. It's 9 p.m. here. Yeah. Hey. Yeah, I tried I tried a different thing out. It's 11 a.m. on a Sunday for me. Karu, nice to meet you. 4 p.m. Yeah. Well, yeah, so this is a nice time to include some more folks east of me. Not so great time for to include folks west of me. So, there's really no winning when it's global. Huh? Ignacio, Ilya, oscillating tortoise sound. That's an awesome. Sorry, that's the winner right there. Pulaska or Pilaska? Pileska? Piles no. Pilasica. Sorry. I'm getting old here. My glasses aren't that great. Yeah, welcome everyone. So, Ivan, so here's the idea here. You need if you want to follow along, you don't have to follow along. If you want to follow along, you can. Um, it's gonna be a little bit. I'm open to extemporaneous, more fluid presentation. So you can go. There's a link in the chat description. I switched it. Originally, I was gonna say, hey, grab some Sonus files. You should do it anyway. That's hey, it's free sound libraries. It's good stuff. But I switched it over. I was like, hey, actually, I think I could assemble a collection of samples from Epic's sample projects, the stuff that's already been released, and just sort of like collect them into one project. And those samples cannot be used outside of an Unreal project, with the exception of a couple of samples. One's a public domain sample, and one is a me sample. Well, actually, there's a couple other samples. I'll go over them in a little bit, but just be aware that, and I'll say which project they come from. But that's sort of the idea. I figured that'd be easier. That way, everyone has a project and it's kind of loaded up and it's got the plugins and stuff like that. So you'll need Unreal 5 7.1 installed in order to follow along. Matt, it's 8 p.m. there. We'll survive. Hey, that's not too bad. Nice. Yeah, let me know if there's any issues downloading. I haven't, I don't know how many people were going to show up. So, cool. Yeah, so let me go to slide deck. Yeah. So, welcome to, I don't know, maybe this chat, I put the chat box in there. Maybe that's going to be awkward there. We'll see. Okay, so let's go to this first slide. This is what I'm hoping to go over today. Okay. I'm going to talk a little bit about preparing the audio editor. I'm going to bring up, oh, I forgot to bring up my notes over here. I'll have to bring up my notes. Oh, there it is. Okay, here's my notes. So yeah, we'll talk about, again, oh, yeah, I should preface this. This presentation really is for folks who are just starting out. If you will it work with 5.2? No. No, you're gonna have to update to the latest. Yep. Don't worry. Like I said earlier, this will be recorded, and so if you need to, try to follow along later on, you can do that. It's just kind of nice right now because you can ask me questions, and that's sort of convenient. Um, right. So this is sort of geared toward beginners. I'm not gonna go into a lot of other Unreal or Unreal Audio stuff. I'm going to be very focused on MetaSounds. Um, if we feel like there's time, maybe we'll do some blueprints or something like that. But that's not really the intention. The intention is kind of to focus on sort of practical and early sort of foothold into MetaSounds. That's the idea here. We're going to talk about what is a MetaSound because there's sometimes confusion about what MetaSounds are. Because I see discussions on Reddit that's like MetaSound or wise, and that's a very weird question to ask. And hopefully this will clarify why. Creating a MetaSound. So we're gonna make our possibly our first MetaSound. I'm going to talk a little bit about the graph and some of the graph properties and how it's different from maybe some other graphs. If you're familiar with Unreal, how it's different from blueprints. I'm hoping to talk about this sort of. We'll like make a basic one shot. We'll make a basic sort of non one shot, which you might just call looping, but it's a little bit more involved. We'll talk about the different types, sources, patches, and presets, and we will hopefully get into a more advanced implementation of of a variation, like a random variation kind of thing. We'll talk a little bit about optimization in pages, MetaSound pages, and those came out in 5.4, and they have been very critical for shipping MetaSounds across the Fortnite ecosystem. So it's good to get into optimization there. We'll talk a little about procedural generation and random streams, which is one of the pillars of MetaSound's uh, design, the architecture to support those sorts of design patterns. We'll get into some basic music design. I won't. A lot of this stuff can kind of go crazy. There really isn't a ceiling. So I just want to kind of get people started on some things like that, so, some of that stuff. And then we'll maybe talk about the role of MetaSounds in the audio production pipeline. I may have by the time we get to the end of that, I may have already talked about that. So this is not necessarily the order in which everything will occur. I just want to sort of give people an idea of what they're getting into. Yeah, great question. Let me put that up there. Boop. I don't know. My feeling is uh probably 2 hours. That's I've got a, my biggest mug of tea, and I also have a carafe of water. So I'm kind of prepared here for a longer one. It could be like an hour and a half, and then maybe half an hour we do questions and answers. Could be something like that. But yeah, so it's a great question. Any other questions that I might have missed? Brighton? Yeah, that's all. That's totally cool, Merle. Um, yep. Yeah, I don't know if there's gonna be another one. We'll see. All right. Yeah, that's fine. That's the idea, Karu. That's my hope here. So let's switch over to a screen share. All right. So here's the project that I put up on the internet. And it's basically just the framework for a project. This should you should have no problems opening this. Let me know if there are issues downloading or opening the project. It has. If you're new, you might not see this. Actually, let me just. This might be your view. I've sort of customized this a little bit. Oh, that's not what I wanted. One of the things that UE5 is really keen on is just showing you the visuals. It's very graphics oriented. um, so you might see something like this, and you'll have to sort of look along the side. There might be tabs that you can open up. And what you can do is if you right click on the tabs, you can undock them. And what we want is a content browser. You have 4 content browsers, but you only need one. So pick one, pick your favorite. If you can't find one, you can open it up on the uh, Windows. Uh, where am I? Oh, my brain is missing. Is glossing over it. Why can't I? Is it a tool? Look at this. Even I can't find. Oh, there it is. And it was right there. It was right in front of my brain. Yeah. So this, I was looking. I don't know why I glossed over it so many times. So yeah, just open up. You can open up a content browser here, and the windows are. they're undockable. You can sort of move them. If you've got a 2 monitor or 3 monitor or 4 monitor, you can have a content browser in every monitor. If you want to dock it again, you can just sort of boop, dock, that sort of thing. So what you'll see is an empty MetaSounds directory. You may or may not see this developers folder. Don't worry about it if you see it. It's okay if you don't worry about it. It automatically generates this directory for you, and it bases the name of the subdirectory on your like computer username. And for some reason, mine is like cut off there. And then yeah, more content browser. A lot of content. And so then you have the sound waves directory. The sound waves directory is where I've put all of the samples. We have an ambient directory, and these samples are from the city sample and the Lyra. Sorry, not Lyra. The what is the project? The actual project name that they released? Valley of the Ancient. Sorry. My brain, it was just code names. Valley of the Ancient. And then we have these are samples. You are free to use them. These are sampled from a drum synthesizer that I own called the Vermona DRM1. It's a sick drum sampler. And then this is some music that I've written for testing interactive music systems. It's basic intro, loop, outro kind of thing with some different features. Then we've got fauna from the Valley of the Ancient, crickets, grasshopper, hawks, etc. Just variations of each of them. Some nice stuff. Then we have some footsteps. One from the city sample, some cement footsteps, some heels, and then rock footstep. We've got a Mozart recording that is public domain from a university, and I've forgotten the origin. Please don't use it. I don't remember what the licensing is on this, but it is public domain. It's really just a demonstration. And then we have some vehicles. I don't know if we'll actually make some, but we've got some vehicles from the city sample. So it's kind of what we got going on here. Cool. Yes, endless content browsers. Yeah, I wanted to I gave a little tour here to give some people time to join the stream and load up the project and stuff like that. So let's make a meta sound. We'll keep it simple. So whenever you want to add content to a browser window, let's go to our MetaSounds directory. And then we could right click in the content browser and you'll see a whole bunch of asset types that you can create. You can also go to this add plus icon and you'll see a bunch of stuff there too. If I should mention a good emergency button is under window. You'll see some layout selections, and you'll see default editor layout under load layout. So if just everything is crazy with your Windows, something's gone really wrong, you can just click that and it will reset it. So, whoops, there we go. It'll reset everything to its default state. So, oh yeah, you can see the content drawer here. The content drawer is a feature that I never use. Some people use it. I think I haven't used it because it's like a quick key kind of thing. But you can open it up with a space bar. I think is it? Or maybe they took that off or it's configurable. Anyway, I just load up a content browser. Most of the stuff that I do is in content browser. It's like not in the actual editor. And I tend to like the content. My preferences tend to have the content browsers on the left side. And the reason I do that is because I actually prefer looking at things in list mode. So if you go to the gear icon, you can change how things display. And I like to see things organized maybe by name. And this is where naming convention, we talk about naming conventions. Naming conventions are really important because they help you organize all these assets. Directories help with that too. Okay, so let's make a MetaSound. So let's go to our MetaSounds directory, and I'm going to right click. You could click the add button, but you want to go down to the audio. Oh, actually, I'm skipping things. Y'all got to keep me on this. I forgot. I was preparing your audio, your editor for audio work. So actually, this is really cool and sometimes annoying. It depends. There are editor preferences, and the editor preferences are set on the engine level. So they carry across projects that use the same engine version. But if you have a new engine, like if you download a new engine version, maybe like 5.8 or something like that, then you might have to set these again. If you work at a studio where they have maybe multiple streams, you might have to change. You have to up those settings when you sync to a new stream. So go to the edit window, and then you see editor preferences, and then you'll see a window pop up, and there were I think 4 things. Let's go to the slide deck real quick. Go to the next slide. Right. So we'll want to set our audio output device. Make sure it's the right one. Maybe it's already using the right one. That might be fine. We want to make sure that we are not using less CPU when the editor's in background. We want to allow background audio, and then I'll show you where the display properties are for MetaSound. It may not be useful right now, but it's good for you to know where it is. So so yeah, if you go to general audio, hold on, let's move things around here. Let me go back to here. Okay. So, general audio, you can see here available audio output devices. So right now I'm using the system default, which is just what I have set for Windows. But if you want to switch it to a specific one, you can do that here. So that may be really important if you've got like a custom audio device or something like that. It's just going to be using your WDMs, whatever drivers have been installed on your machine. That's what's going to show up. But that's the spot to do that. Sorry, was there a question? I have not personally gotten into collections, but that's because collections were really weird when I started Epic, and so I got dissuaded from the usage. Originally, collections would automatically get synced to the project. It would like automatically submit to Perforce, and so I didn't want to touch them. I don't. I think you can have local collections now, but I sort of never got into the use of them. They are very useful though. Okay, so then under general performance, so if you go down to performance, you'll see an option here under editor performance, use less CPU when in background. Make sure that is false. It should be false, but make sure it's false. What that does is basically it throttles the frame rate when the application is out of focus, and we don't want that. And the reason we don't want that is because when you're working in audio, the frame rate is also your audio update rate, and so data that you might be monitoring a session, play session in the editor, and also going out of focus to do something, maybe kick off some recorder, or maybe you're going into some other applications, and you want to be able to still monitor the audio for whatever reason. You can't do that as successfully if that throttles the CPU. So Then we want to go to allow background audio. So that'll be under level editor. So go down to level editor, and then miscellaneous. And you'll see down here under sound, allow background audio, tick that on. And that, just like with CPU, that'll allow audio to be audible when the application is out of focus. So if you're in some other um, application, like I mentioned before, you can still monitor the game audio. And then, yeah, the last thing is just sort of you go to content editors, you'll see that there is a MetaSound content editor preferences section, and you can do all kinds of really useful things. You want to change the color of the pins and nodes, you can do that. You can adjust your analyzer settings, and excuse me, you can reskin the widgets. So there are a lot of settings here. It's I'm not really gonna advise you on what to set here, but just to know that this exists and you can go in here to adjust things. Cool. All right. Now let's make our first meta sound. Um, yeah, we'll get started here because I know there was another thing that I added actually between making your first meta sound and this, but we'll just call it we'll call it MSS from Meta Sound Sort. Oh, sorry, I just went through that really fast. Let me do that again. I just realized that. Just realized that. I'm going down here. I'm selecting. This is so rote for me. I go to audio, go to Meta Sound Source. Should be at the top here. You can actually set what shows up here. That was in the audio settings too, actually, which was sort of glossed over. But yeah, the MetaSound source is what you're looking for. There's also a MetaSounds little category here, subcategory, and you'll see a MetaSound patch. And we'll get into the difference between those in a little bit. What we want is a source, and we're going to call it MSS MetaSound source underscore my first MetaSound. And you'll see an asterisk on the tile, and that indicates that that is dirty or unsaved content. And I'm just going to go Control S while it's highlighted, and it will save it. It's just a thing because otherwise it hasn't been saved. So yeah, it's and you'll see me do that sometimes. I think a lot of us have that tendency to sort of Control S every once in a while. Um, Yeah. So, okay. So we'll make a very simple meta sound. Um, but let's. I want to sort of. We'll do it really. Okay. Here's what we'll do. We'll do a classic two pop, not Tupac. Two pop. So right click on the graph in the middle of the graph. So center yourself in here. You can right click and then move it around. You can lasso with left click drag. And we'll get into some of the layout here in a little bit, but I just want you to right click. We'll just get something going. Right click and then type in sine as in the wave and not the thing you look at. Okay. And if you left click, you can drag it around. You'll see a bunch of properties on the left side. These are inputs. You'll see on the right side output. So that's the sort of general flow of this graph is left to right. So you'll see usually things that little pins that are facing to the right are going to be flowing into the graph. And then pins that are facing to the left, the graph will be flowing into them. And so if we look at this sine node, you'll see a bunch of properties on the left. This is data that can flow into this node, and then out on the right side, you'll see data flowing out of this node. In this case, audio flowing out, and properties that set the audio flowing into it. And if we click on this audio pin, we can drag it to the output mono, out mono, and that will make that connection. And now we have a meta sound that we can hear. And actually, you'll see that now that I've made changes to this meta sound, the tab shows an asterisk after the name, again, letting us know that this has unsaved work in it. So if you want to be safe, hit that save or Control S. And yeah, now we can play it. You can hit the play button up here. You see there's transport controls. There's a play and stop button. And you can also use spacebar to audition like you would maybe in your DAW. And if we play, we can hear a sine tone. Look at that. And that's actually, while it's playing, you can sort of hover your mouse over. Oops, hover your mouse over. Okay, maybe not. Hover your mouse. Hover your mouse. No. Okay. I wonder if did I do something? I did. Hover your mouse. No. Okay. Clearly I've reset some sort of setting. Let me see if this is one of the things about editor preferences is you do them once. All right, let's go to the MetaSound editor, and let me just get close here where I can see. Yeah, yeah. Okay. Actually, let's display these axes. This is actually a good one. I don't know if that's already on for you. I don't know why it's off for me. Okay. Pi. Yeah. Okay. Yeah. Is it loud? Okay. Let me adjust the volume, overall volume for this this meta sound. This might be a running thing. If I go to the gear source here, the source tab, under the details, you'll see a bunch of source properties. I can go to the volume here, and it will just adjust the overall volume. This is to 50%. So this should be a little better. Yeah, Caro, I agree. That's how I also feel about Reaper. uh, by the way, one of the sticking points that I don't remember who I heard this from. But it's like Pro Tools is ubiquitous, no, ubiquity. It's in studios is because you can't customize it, right? So anyone can go to any studio and they'll just be able to operate it and there won't be an issue. Customization is very cool, but it also makes it like very difficult for random people to come in and use your stuff. Okay. So right. So here's the MetaSound graph. We can sort of visualize the. I haven't. There's supposed to be an analyzer that shows up when I hover over there's some sort of setting that I don't know how I got it off. Some kind of setting. But is a little loud. Still, let me go. Let's go. I'll go 20. Let's go 0.35. We'll go 35. There we go. Is it better? We'll see. Okay. Still a little loud. All right. How about we'll go 20%. Is that better? Oh, it's louder than me. Okay. What I could do is up my mic pre, but I think I'm just gonna start distorting if I do that too much. How's this? Is this am I clipping here? Oh, there we go. Right at the edge. Right. I'm about. How's that? Is it better on my side? This is like a Zoom call. Yeah. Okay. Um, we'll start there, and if people, yeah, we'll get let the dust settle on the. Okay. Thank you, James. Where was I? Right. Uh, this node is generating a sine tone, and then what's happening is we this connection is passing that uh, of the data of that sine tone, the generated sine tone, to this output, the graph output. And this is basically the exit point of the MetaSound graph. It's going to the audio engine, and the audio engine is taking that, and then it's going through its render chain, and then it's going to your audio hardware. So, so yeah, let's briefly talk about what a MetaSound is, and maybe what it isn't. So the marketing around MetaSounds was very successful. So much so that a lot of people assumed that MetaSounds was in reference to the entire audio engine, and that is not the case. And I mention this because it's a very important frame of reference. If you are, say, coming from a background uh, where you're used to middleware, Fmod or Wise or Cryware, then you are accustomed to thinking of the audio engine as a separate thing from the game engine. And so this a MetaSound is working in MetaSounds is reframing working in Unreal Audio is reframing that assertion to think more of something that's well integrated into the rest of the engine. MetaSounds are more like a right now what we're looking at is like just a single source. So that would be the like an fmod event or in audio wise maybe it could be considered maybe a an event, or it could be considered just a sound effect, right? Like Wise has synthesized sounds, um, and that's just a sound effect, or like a external voice sound effect, right? And so this is basically just a single source. The thing about MetaSounds that is a little bit maybe more um, complex is that it's also a framework. So if we go back to my slide deck and we look at my list here, so what we're looking at is a DSP graph, right? It's uh, it's a digital signal processing graph, and the power it offers is exposing processes that would normally only be accessible to programmers, to audio programmers, exposing those to designers. In the same way that materials, if you're familiar with Unreal or similar, or shaders, maybe you've heard, exposing powerful rendering features to tech artists, right? In that same way, we're exposing powerful um, audio signal processing features to audio designers, audio artists. And so, what we're really looking at is a render graph. And if you were to use maybe an analogy that maybe would be more one to one, would be something like if you like Max MSP, um, it would be the signal processing part of it. Reactor, if you're familiar with Reactor, it'd be similar to that. Pure data is another example. So those are examples of graph representations of signal processing, and the idea behind those, the power that they offer, is bringing these sort of low level audio processing features and making them available to designers to do crazy stuff. So that's the um, that's the sort of gist of it being a render graph. The sound source is just a source. It's just a single, it represents a single sound event. And so um, there there may be but it's built in the context of the greater Unreal Engine, right? And there are a bunch of design features in Unreal that are not audio specific, like blueprints, like state tree, like data assets, like data tables, like chooser tables. All these sorts of features are domain agnostic. And so they are when developing something like MetaSounds, that larger ecosystem is considered. It's part of the development expectation. And so things like blueprints, you will need to, if you want to be effective working in Unreal, you will need to learn blueprints. And so there may be places where you think maybe the middleware would handle some of that logic that might be more appropriate in blueprints. So there's a lot of overlap when we're talking about logic, behavior, audio behaviors. Some could be done in the MetaSound, some could be done in blueprints, or both, or either. And so part of developing your project might be determining those things. I will talk about some best practices that we've discovered or have emerged, but it is a tech that is constantly in development, is constantly changing and improving. And features are like, for example, Pages is a great example that we'll talk about later on of a feature that is oriented around optimization, but was brought about because we had to deliver a project, on many different platforms, including lower tier platforms, right? So that that's something to consider. There's sort of this is a constantly evolving landscape, and so it's good to keep up on it. It's good to watch the patch notes, but it's also just something to sort of appreciate that best practices will also evolve. Okay, um, so yeah, what we're working on right now is MetaSound source, right? We select the MetaSound source. That is a source, and it can be played like any other sound type. If you're familiar with previous Unreal sound types, you can play it in the same with the same functions, and the we'll get into a little later. We'll see the subgraph. You can create subgraphs or sort of utility graphs that aren't sources themselves, but function as reusable chunks of designs, which we call a MetaSound patch. And it's also a framework to build audio systems. Like you could build like a great example actually is Patchwork in UEFN. If you check out UEFN or Unreal Editor for Fortnite, you'll see there's like a 3D modular synth called Patchworks, and it's completely built dynamically as a MetaSound under the hood. So it's like an audio system, runtime audio system that is powered by MetaSounds. So, and we expect MetaSounds to populate more and more of the render stack in Unreal. So you're going to see more and more of them. But hey, Nathan, good to see you. Okay, yeah. Thank you, Chris and Eliot, for verifying that. Okay, so let's get back to our Tupac. Okay, so let's add. You'll see this sort of warning over here. This is telling us if you hover over it, it'll say, "Hey, look, this needs to have a connection." And if I hold Control and I scroll in, I can zoom in past one. You can actually zoom out with scrolling out and zooming in, scrolling in, or scrolling up to in, down to out. And so if I hold Control, then I can go extra big. But what I want is if we hover over this warning, we can see, hey, this is looking for a connection. And it's talking about something about one shots. And so what it needs is a trigger. And basically what the reason this source um, is distinguished from a patch. We'll look at a patch. A patch and a source, a MetaSound source and MetaSound patch look exactly the same. The difference is that the MetaSound source has special inputs and outputs that interact with the audio engine, with the greater audio engine. So when we call play, there's a trigger that comes through this input that can trigger events on the beginning or the onset of our playback. And we can send a trigger to this output to indicate to the audio engine, hey, we're done playing. And you can free up the resources. Sorry, I didn't scroll down there. We can free up the resources for another sound to play, right? So if we send a trigger to this on finished, it will stop the sound. Now there are two types of sounds um, when we're talking about this one shot or non one shot or looping. Sometimes we call it, but looping is kind of a terrible word now because like you could have a sustained sound that is not looping anything. so it's it's like a holdover from the old tape loop days, right? But what does looping mean? So it's easier to sort of think of as one shot as like as momentary sound. Another way to think of it is like, does the meta sound itself manage its own lifetime? Does it manage its own stop, basically, or is it externally managed? And this unfinished is basically having that unfinished there is telling the audio engine this meta sound intends to control its own lifetime. And so you should wait until it tells you when it's done. If we get rid of this, then we are indicating to the audio engine we're expecting some external thing to manage the lifetime. So that's that, and that has implications because typical one-shot sounds, heuristically, are very short, like a footstep or a gunshot. And so when the audio engine is deciding whether or not a sound should be rendered, one of the things that it looks for is volume, priority. When deciding, hey, this sound is not going to be audible, when it's a one shot, the audio engine as an optimization will just not ever play it. It'll ignore a play call for it. It'll just throw it out. If the sound is not a one shot or a looping sound, then it will try to get that sound back. It will check to see if it should be audible later on. So understanding that is really important when you're talking about a a one-shot sound, because I get a lot of people who are like, "Hey, um, I can't hear my sound when it goes out of range and I come back in range." And this is usually the reason, is that they don't want it to be a one-shot, but they've left this in. But we want this to be a one-shot. In fact, we don't have, any control over anything going on here, so we actually want to have the appropriate length for our 2-pop, right? So first of all, it needs to be a 1 kilohertz sound, so let's change the frequency of our sine wave, from 440 to 1000. This is gonna be really annoying sound, so we want it to be very brief. We know that we're getting a trigger when we play in, and we want the sound to play for a short period. We in fact want it to sound to sound for 0.42 seconds. So, which is basically like 1 frame of video. So let's right click. We're going to type in trigger delay. And then we're going to go 0.042 in the delay time. This is this unit. Whenever you see time, the unit is seconds, unless otherwise indicated. And then we're going to take our play trigger. We're going to go into the trigger delay. This will delay the trigger for this amount of time. And then when it's done, we're going to go into the on finished. And I'm just going to move these close to each other. And if you've got this sort of crooked and you're very like finicky about the wires, you can select these and you can right click and you'll see under alignment, there are some options to sort of align nodes. And one of them is straighten connections, which I've just memorized as Q. And then you get a nice straight wire. And now when we play, it will actually stop itself. It will the trigger will come in, the sine node will start generating our 1000 kilohertz waveform. This delay will delay the trigger input for a very brief period, and then it'll output the trigger after the delay, and that will go to our output. And our output will tell the audio engine, hey, this meta sound is done playing. Stop it. So if we hit play, we get boop, boop. Cool. And now you've got your 2 beep. So you can cue the ADR. Hi, Ivan. Yeah. Yeah, similar to pure data or the MSP, the signal processing part of Max, MSP. Yeah, Caro, that's correct. This is a MetaSound source. Hello, the horse. Mr. Horse. All right, let's save our beautiful 2-pop. And I'm going to close this. I'm going to go back to, instead of calling it our my first MetaSound, I'm going to hit F2. You could also just sort of click the name, or you could right click and rename, but I'm going to F2 to rename. I'm going to go MSS. I'm just going to call it 2-pop. And we can actually audition it here. We just press the play button on the tile and we get to hear it. Cool. So I feel like this has taken a good chunk of time. Nice. Yes. Welcome back to MetaSounds. Right. Let's go. Let's move to the next thing on our list of things. Let me collect our notes here. Right. So we wanted to go to. Right. So let's talk really quickly about. Oh, I forgot a basic layout. Let's do the basic layout. So we were sort of functional there just to get things going. But yeah, here at the top, actually very similar. You can reset the layout, and that will clear everything up. But just be aware of that. There's also a list of all the windows here. So if you can't find a window, maybe it's been unchecked. So just you can look there too. We have at the top we have some basic file stuff, save, uh, go to, and browser. This goes to the associated asset. You have the source properties. If you click that, you have the MetaSound specific properties, and you'll see some cool stuff there, including output format. You can, you know, put yourself as the author. Dan. You could give it a special display name. This is how it would show up in other MetaSounds. You can give it an access flag. So this, you can say this, hey, this is a deprecated sound, or this is referenceable. We'll talk about referenceable, but referenceable basically means that it's accessible to other MetaSounds and be used as like a custom node. And you don't want necessarily to do this by default on your MetaSound sources. Before 5.7, this was the case. After 5.7, this is not the case. And this is because every sound would show up as a possible node. It was very annoying. So now you have to indicate that you want it to be accessible, referenceable in other MetaSounds. You can the trigger. Can you assign a trigger to the button? Yeah, we'll get into that a little bit. Maybe in a little bit more a more interesting MetaSound, maybe. Uh, if you go up a little bit, you have members. Under members, you have inputs, outputs, and let me unhide this. Variables. Inputs are There are different kinds of inputs. There's data inputs that could be like, for example, on play. It comes from the audio engine. There are inputs that are useful because you want them to come from gameplay. You could create a new input and feed whatever gameplay data you want into it. And There are sometimes we want inputs because they're just useful for us tweaking. Sometimes we want inputs because they're useful for editing variations, and we'll get into that. We'll get into presets. And then there's outputs. You can output. Obviously, there's the sort of the data outputs, like on finished or mono out or audio out, are very important. But you can also feed arbitrary data out of the MetaSound to back to gameplay. Like for example, you can have an LFO and then feed that out of the MetaSound, and then have that feed to like a platform in your project or something like that. So you could have like music synchronized platforms moving around and stuff like that. It's very powerful. Then you have interfaces. Oh, sorry, variables. Variables are cached data that only exist inside the MetaSound, and we'll get into that a little bit. And then we have interfaces. Interfaces are ways to add inputs and outputs to your MetaSound. What's powerful about interfaces is that code can query whether or not an interface is implemented. So, for example, let's say you've got a vehicle interface, like for your car sound. The program can ask the MetaSound, "Hey, does this MetaSound have this interface?" And can know that before playing the MetaSound or doing anything to it, and then it could make a determination. Oh, this has this particular interface, so we need to treat it this way, and this is the kind of data that we feed to it. Or this MetaSound has a different interface, and so we feed this other data to it, right? So you can treat the MetaSounds differently based on the interfaces they have. There's a bunch that ship by default. The one-shot interface is the one that is you're most likely to interact with. If you didn't want it to, we'll play around with this later on, but you can just get rid of it. You can just trash it here. If you delete this node, it's not going to do anything. The interface will still exist. But if you delete the interface, then the node will go away. And then the audio engine will know, hey, this is not a one-shot sound. We should treat it like it's sustaining forever, or until some external thing tells it to stop. What are the source and MetaSound buttons just below the name tab? Yeah, the source, these are source properties. So if you click source, you can see here, under details, you'll see source properties, which are basically like any sound source in Unreal Audio has these properties. Whether it's a sound cue or a sound wave or a simple sound or a procedural sound wave, that's what will show up here. And these are properties that are relevant to the playback of the sound in the audience, like the volume, some kind of pitch playback scaler, its sound class, attenuation settings for spatialization, routing like effects inputs, bus routing, submix routing. So these all have to do with modulation, some voice management, like how is the voice treated in the audio engine, priority, etc. So these have to do with how a sound is played back, treated when it plays back. You create MS interfaces yourself. Yes, you can create MS interfaces yourself, but right now it can only be done with code. We hope to make them something you can make, kind of like blueprint interfaces, but they're not that way right now. I was experimenting with 5.2 and trying to make a whole beat. Do. Yeah, Druid Sandstorm. Very interesting concept and powerful. I would like to dig deeper. Yeah. You can totally make Sandstorm with MetaSounds. If you're from modular synths, you'll see a lot of familiar vocabulary in MetaSounds. If you go to the MetaSound button, then you'll see MetaSound properties show up here. And that's like the output format. Here we have mono, but it could be stereo, quad, surround, etc. This will get populated with more formats. And some other stuff, keywords for searching the MetaSound, that sort of thing. So, yeah, cool. Right. Where was I? Right. Interfaces, yeah. So you'll see some other cool ones. UE attenuation. So you can get like the distance, the sources from the listener orientation or source orientation. So the orientation compared to the listener compared to the sound. The start time. So you'll see like on the play functions, there's a start time input. So you get that input and then you can do something with that input, like seek into a WAV file. Spatialization. So it'll give you orientation, azimuth, angle, and um, altitudinal angle. And yeah, I'll see a harmonics one asset, a music asset. Uh, the UE ones are super useful. The harmonics one is specific to a particular ecosystem. But yeah, you can play around with those. Just know that some of these, if you're copying and pasting, you just want to double check. Sometimes you can end up getting duplicate inputs and outputs, or yeah. So, but yeah, you'll see they're organized by namespace. You can create your own inputs, you can create your own outputs, you can create your own variables. So in that way, it might not be an interface itself, but you can create some custom inputs. So yeah. All right, let me do a quick jump to data, a little data, um, a little data explanation. So, digital audio, we're Moses' opinion to add inputs to the mixer nodes interfaces. Is that something coming up? Maybe mixer node. To add inputs to the mixer nodes. Yeah, I'm not exactly sure what you mean, but we'll talk about. Yeah, I can show adding inputs. I think that's pretty useful. I think we'll see a version of that in the basic. Yeah, we'll do the basic one shot. Right. I just want to sort of explain a little bit about the data so that's understood. And this is something that is kind of important also, uh, if you're familiar with blueprints, but maybe you haven't messed around with MetaSounds. Again, MetaSounds are not blueprints. They look a little bit like blueprints. They use the same graph, parent graph type class in Unreal, which is used all over Unreal. But they are not actually blueprints. And what they are is actually a render graph. And the if you dig down deep in your digital audio 101, you remember that uh, digital audio is represented in samples, right? And it's rendered in buffers. And the reason we render in buffers is CPU optimization, because CPUs are sort of have optimizations for doing uh, chunks of operations at once. There's certain tricks where you can do operations like four multiplications for the cost of one, and then there's other things like cache level that can optimize as well. And so it's just better optimization for you to process audio in chunks rather than one sample at a time. You've seen this in your video as well, right? Um, Graphics also update in big chunks. They update in big buffers as well, and they'll actually swap the screen out. Right, so while you're looking at one screen, they're actually building the screen behind it, a new one, and then they swap out which one you look at. And same way with audio, you're listening to one buffer while the next buffer is getting processed. And so yeah. And if you've ever seen screen tearing, that's because your buffers are not getting updated fast enough, and you're seeing the buffer getting written in real time. And this is what we call a buffer underrun. We have the same thing in audio when you get little hitches in your audio because the buffer is not done rendering when you're asking to hear it. So it's a little bit of a race, right? You want to your little processor has to update a buffer and then pass it on to your audio hardware, and it keeps doing that. And as we know from our DAWs and recording, this introduces what we call latency, right? Latency. And if we have shorter buffers, we have shorter latency. This is really important, obviously, with recording, but we up our buffers when we're doing mixing and processing because we're running, fancy altiverbs and expensive amp simulators. And so all this stuff is going to introduce buffer latency. And the bigger and chunkier our buffers, the the uh, the more likely we're going to meet our rendering expectations. Right, we're going to deliver buffers that are fully rendered. So right, so that's the same thing with MetaSounds. MetaSounds are rendering in buffers. By default, MetaSounds render at 48 kilohertz, regardless of what your audio hardware is set at, and they are rendering uh, at 100 times a second. Both of these are tweakable. You can adjust them by platform. So, like for example, if you're delivering on a lower tier platform, maybe you want to only render your MetaSounds at 22 kilohertz or something like that, right? You can totally do that. But by default, it's 48 kilohertz, 100 times a second. And that means our buffer sizes are 480 samples long. And so you can, yeah, so you can see here, I've sort of described we got sample rate and buffer rate. And you can see at the top, I have an example of an audio buffer. that starts at the 0th sample, and it's just floats. It's just numbers, right? That represent the amplitude. And in the case of MetaSounds, it's 32-bit float. And you have 480 floats starting at the 0th index all the way to the 479th index. And then you have, if you skip down here, we have uh, just regular variables like a float variable or an integer or the time variable that we saw or Boolean or a string. And these update once per block. All right. Once per buffer. So they update it 100 times a second, which is not bad. But if you know your Nyquist, which y'all should, let me stare at the camera. Y'all should know your Nyquist. Then that means your expectation for this data has to be, for capturing the data, has to be half of your sample rate. So the sample rate for an integer or a Boolean is going to be 100 times a second. You should not expect it to be represented well over 50 times a second. And under that, you can get aliasing. If you have an LFO that's spitting out a float value, you can get aliasing. It's just your sample theory, right? So the expectation is that these parameters are going to get very slowly updated. They're going to be like, oh, we're changing the frequency a little bit, or we're updating this enabled or disabled value, once or twice or whatever. And so it's important to sort of appreciate that all of the data is processed in these buffers. Now, the way that we get sample accuracy with events is with the trigger. And the trigger is not an execution. The trigger is specially marked samples. It's just an array of integers, specially marked sample indices. And so you can see I've written here under trigger, I have 3 indices, 42, 225, 457. And what this is basically communicating to any trigger input, hey, whatever you do, maybe it's like an envelope generator, or it could be a wave player. I want you to start your event at this sample. So the power of triggers is that it allows you to have um, basically buffers, like be able to start an event mid buffer. All right. So this is how we can achieve sample accuracy and the with events, with triggers. So what I want to show you is a little demonstration of that. So let's create a new MetaSound source, and we're going to call it MSS sample accuracy demo. All right. I hit enter to open it up as like just me being speedy. And so then what we're going to do is we're going to go and trash our unfinished interface, our one-shot interface. So go over to our interfaces, and then we're just going to hit the trash icon and get rid of that. I'm going to save it. And then we're going to change the MetaSound to a stereo MetaSound. So go to the MetaSound properties here, go to the output format and select stereo. And then what we're going to do is we're going to right click. We're going to type wave player. And then we're going to hit the number 2 or type stereo. And you'll see a wave player stereo format, wave player. Okay. Now, if we make some space over here and go down to the Mozart demo, we can see I have a bunch of clips from this public domain performance of Mozart operetta, and you can hear them. They're like a couple seconds long, I think. Yeah, 2 seconds long. I just chopped them up on the Zero Crossing and Reaper. They're just little chunks, right? So what we're gonna do is I'm gonna grab this first one and I'm gonna go over here and see this little arrow icon. I'm gonna click that and it's gonna make it go in. You could also open this up and type Mozart underscore _01 and you find the sample there. You need to audition it to make sure it's the right one. And then, so we've got this Mozart sample. And then what I'm going to do is I'm going to just connect them, this left to the left and right to the right. I'm going to select the on play and press play, click that, connect that to the play. And then I audition and we can hear it. Now we haven't told the MetaSound to stop, right? So it's still playing. You can see it's still playing. But what we're going to do is we're going to actually take this wave player. We're going to copy it, Control C, and then we're going to paste it. All right. Now, what I'm going to do is I'm going to change this up a little bit, but let's place it a little diagonal like this. And then right click, I'm going to have, let's get a stereo mixer 2. Okay. And now instead of the wave player going directly to the output, we're going to have the mixer go to the output, left to left, right to right. And then we'll have the first wave player going in this first one here, the second wave player going into the second one here. And then on the second wave player, let's select Mozart 2. Right? And then what we're going to do is when this wave player is finished, we're going to play this wave player. And now when we play, we'll hear this one play, and then you'll see a little trigger blip on the white wire, and then this one will play. And we'll hear 4 seconds of Mozart. There we go. And this was sample accurate, right? This is concatenation happening sample accurately. But let's see if we can improve this. Because if we want to hear the whole thing, this is going to be really like this crazy ladder of wave players. So let's redo this with only the one wave player. So we'll delete those. I'm just hitting delete while I'm selecting them. And we'll go back to this setup here. And then instead of having the Mozart directly in, what we're going to do is we're going to drag off of the wave asset and it'll open up the menu. And we're going to want a random get of a wave asset array. Or no, sorry, not a random get. Sorry. Just a get of a wave asset array. Boop. Yeah, we don't want to. Yeah, let's do a little different. Let's do a little different. Okay. And then what we're going to want is an array of our Mozart wave assets. And an array is just a big collection of them. And so let's promote this to a graph input. And we're going to call it, let's call it our Mozart array. Okay. And then what we'll do is we want all of these, but we want them in order. We want to select them in order. So select the top one, the first one, and then shift, click the last one. And that should put them in order. And with the Mozart array selected in our graph, in our graph on the input, you'll see down here, array element. This is our Mozart array input and all of the properties for it. You can see this wave asset array. And we just want to drag these over that input. And then if we give ourselves some space. Oops, if we drag this open and we go here to this line and sort of drag that back, you can kind of see, and then you can check, is this all in order? We want 1 to 15. And if you have them in order, well, what we want to do is we want to um, repeat that order in sequence. What we need is some way of counting. And so let's make a trigger counter. We'll get into an example. I hope we get into an example with multiple wave players. But let's see if we can keep it simple for now. So what we want is is to where was I? Right, triggering the next one, and actually let's do yeah let's yeah we'll do the counter one. We'll do the counter way. We'll do the counter way. So let's grab from our inputs. There's different ways you can do this. I did this a different way previously, but the nice thing is the counter will automatically loop for us. So what we can do is we can grab the Mozart array input, and then we can get our number, the number of indices, and we'll set that as the reset count. So what that means is this counter will count up at a step size of 1, starting at 0, and it will loop, it'll reset its count whenever it gets to hey Stephen, welcome. Whenever it gets to the number, which if we look at is 15 total, when it hits 15, it'll reset to back to 0. And then we're going to take the value of that count and we're just going to convert it to an integer. So we're going to go to int, and we'll see float to int. And then we're going to pass that in as the index. And then what we're going to want to do is what we want is to indicate to this trigger counter, hey, we need you to increment, right? To go up 1 value. The problem is that our onFinished is over here. We won't know when we want to increment until we're finished, right? So let's we know we need to trigger this again. If we do this once, it will just do the first one, and then we'll be done, right? We don't want that. So let's stop it. What we know, we need some other trigger to come in here. So let's drag off of this input, and we'll have a any trigger any. We want 2. And this is basically just a pass through, or you could think of it as a trigger mixer. And it'll accept triggers from any trigger input. It'll combine them and then output them in 1. So on play, we want a trigger, but then we also want something here. And so what we have is under the wave player advanced, you'll see an on nearly finished. So we saw on finished before. We've used that before. But now you see on nearly finished, and on nearly finished is a special type of trigger that looks at the next buffer. So it's like a look ahead. It's a 1 buffer look ahead. And what it does is it will trigger the next. It'll output triggers that are upcoming, that are in the next buffer. So it's like an advanced trigger. And so this is how we can sort of prove out that triggers are not execution sequences, but are actually data. Um, is we can save this as a variable. We're going to save this. We're going to cache this. So promote this to a graph variable. And if you want to get rid of this big thing here, you can do that. It'll still show up. But the idea is, okay, I want to know when you're just about to finish. I'm going to save that. And now it's available to me right here. And what I can do is I can, just like an input, I can get this. But the thing about this graph is this is this. These are the same. This is the same information. And so if I want something next time around, if I want something what's coming up, then I will retrieve when that time has come, I need the previous version of that, right? It's a little bit like Back to the Future, right? Something's about to happen. I have foreknowledge of that. I need to save that information and then access it the next time around when I actually get there. So, and if you try to use this connection, it won't work, right? Because this is the same data, and you can't set the same data that you're retrieving from on the same render frame. You can't set data and retrieve from that data into itself, upstream from itself on the same render frame. You can do downstream from itself, that's fine, right? Think this is where it's data flow. You got to think left to right. Everything is streaming from left to right. So if we wanted to use that on nearly finished downstream, we could totally do that. But upstream of setting it, we can't. What we can do, however, is get the previous version of it. If you sort of hover over, you can see there's a get delayed. If we hold Alt, we'll get a version of that with a little clock on it. That means this is from the last buffer. This is the data of this variable, the value of this variable from the last buffer. And with that one, we can connect because, hey, that's already been set. That's fine now. On the next frame, we can use that information. And so what's going to happen is when this finishes, or it's really when it's about to finish, it will trigger this. This will go up here. Let's say it's frame 42. This will trigger. It'll update everything along the pathway here, and it'll play. It'll call play again, but that play will be on the correct frame when it actually ends, because this time around it'll be actually triggering on finished. So on nearly finished is an advanced version of on finished, and assuming you didn't do anything to the variable data between then and there, it should work as expected. And this is a slightly different way that I've done this before. I have it set up differently over here in my reference, but we'll just see. I think it'll work. No, didn't work. Okay. This is what happens when Dan gets experimental. Let's okay. So here's how we're gonna do it. Hold on. Let me make sure I didn't. Because I feel like this counter. I think it's the counter. Oh, wait, I did that. 2%, 1. Reset count. Yep. Yeah. Okay. All right. So now Dan has to do what he did on his reference graph. Okay. So what we're gonna do is we're gonna replace this counter with some math. I think y'all can handle it. But what this means is we're going to keep track of our index in the same way. So we are going to want let's add a variable called index. Oh, I guess we could just pull off here. Index, graph variable. There's our index. And then what we're going to want is we're going to increment the index, but we're going to want the previous index. So just like our on nearly finished, hold Alt when you drop it. This is going to get our previous value, set value of the index, previous buffer value. We're going to add 1. And then we're going to use a modulo. Modulus operation, sorry, modulo. And this is a division operation. If you're unfamiliar with it, it's a division it's the remainder of a division operation. So I'm dividing the index, our incremented index, by the total number, and it'll give us the remainder. And so this will create a cycle, of incrementing cycle of indices. And then what we'll do is we will, I think this is we're going to set the value, int value. So we want a value, integer value. And this will be where we set the index value. So I'm going to go target value. This is this. So basically our next index is going to be the value we want. And then we will set index here. So under our variables, we can just set index. There's a yeah. Yeah. Yeah, there's maybe I missed something. We'll check it out. We'll check it out. Cool. And then what we'll do is we'll move. How do I have this set up? Oh, okay, yeah. Yeah, so we'll just move our trigger any. So let's have the on nearly finished go into here. Oh, was this what I didn't set up, Willem? Is that what you're pointing out? And then instead of, yeah, so then we'll do this, and then we'll have this and this. I like it. Was that what I was missing? Yeah, thank you for the check. We're doing it manually. That's all right. It's a little more exciting this way. I think what's important to sort of realize is you can actually do a lot in MetaSounds. Even if there isn't a node for it, you could probably create the functionality with composition. But this is how I have my reference set up. So let's see if my reference holds water. There we go. Now you can see the triggers. Beautiful. Rootaloo? Anyway, yeah. Willem, you were saying that I made a mistake with the counter method. I feel like the counter method should have worked, but I acknowledge that I might have missed something obvious. Oh, you know what it was? Probably was where the counter was, right? Well, was it? Oh. Okay. Yeah, I feel like the trigger counter should have worked, and I probably just missed something. And you can review the stream and go and point it out. That'd be great. Yeah. Let's move on to the next thing. Cool. All right. Let's what did I have up on the docket here? Oh, right. Let's make a random, like a basic random selector. And I think this is one of the things that I want to make sure folks understand, because there is a sort of assumption when you're talking about meta sounds, is is there an expectation that I have to make a graph every time I need a new meta sound? No, that's not the case. You can make meta sounds that are more generic. So let's call this random basic. We'll save it. We'll open it up. And this is gonna be a much simpler graph than one we just made. Let's get a mono wave player. Mono wave player. And let's connect the mono out to the mono out mono on finished on finished. Look at this. Boop. And on play play. Actually, we want random. Let's go from the on play. Let's do random wave asset. And you can go on next play. That's fine too. Like it doesn't make a difference. But we want the value output to be our wave asset. Oops. Oh, I did wave asset bank. Sorry. Um, random wave asset array. That one right there. Wave asset array, not wave bank asset array. We might get into wave bank. Oh, ugh. We might get into wave tables. But it's not planned. And then our input will be an input. Sorry, our in array will be an input, and we'll just call this sound waves. Save it, and let's let's see if it works. So with our sound wave selected, let's find our font. Let's go to our fauna. I'm feeling that. And let's go to our ren. And we'll select all of these and just drag them in, boop, to the little default value. And so now we have an array of our bird sounds. And if we hit play, it'll randomly select between them. Now we could do this, enable shared state, and it'll basically have our no repeats activated. You can hit, put something in there. That's fine, whatever. Just be aware that shared state is not something you can audition in the editor at this time. I'm hoping that we can have that later, but right now you can only hear shared state when you're actually playing and auditioning the game. So previous example, if you are using a delayed on cue point, will it work similar? I mean, no, there is no. You would need. Hey, Gunter. Yeah. So the question here is, delayed on cue point, would it work the same as on nearly finished? Or would it be too late? It'd be too late. Because what you would need is an on nearly cue point, right? Yeah. So the cue point's good for triggering things same frame, but if you need to know it in advance, then it's now you could game it. I've seen people do this where they go in and they adjust their cue points to be 480 samples in advance. You could do that. But that's something to be aware of. Yeah, is that this on nearly finished is a special case. And so you would need an on nearly, like you need to look ahead for other triggers if you wanted those as well. And I think something to sort of understand or appreciate about look aheads for triggers or trigger events is that you don't necessarily like that. It's not something you can do in every case. For example, on play it happens the same frame that it receives the on place. There's no look ahead. Or if your sample is one buffer long, there's no look ahead. The is under a buffer maybe. Think about that. Like there's no look ahead if there isn't time to look ahead. And so it's not always going to work. But a cue point could be one of those ones that maybe they added. I think the trick is that with the wave player, there's like no end to the features that someone would request. And so it's kind of hard to develop like an all-in-one solution. All right. We got random rens. um, let's randomize the volume. Someone was talking about volume, right? Volume input. So volume is a scalar on the amplitude, right? If you take the amplitude of a sound and then you apply half to it, if you multiply it by half, then the amplitude will shrink. It'll get smaller. If you multiply it by 0, it'll be silent. If you multiply it by 1, there'll be no difference, right? It's a multiplication. Um, so you could use a mixer node, which is fine. You could do a mono mixer and then just have sort of a dangling input like this. Or we could have a multiply audio by float instead, and it's the same effect. And we can check it. We can go, okay, let's listen to that, and then we can go like 0.25, and it's quieter. We could also add a input here, which which could just be to some, we could call it volume. And if we went down to the bottom of this input property, we could see knob and switch it to slider, and switch horizontal to vertical, and linear to volume. And now we have a a decibel based volume slider, right? It's inaudible. We could, okay. But we don't want that. What we want is a volume range. So let's do volume. Let's select the float property and instead say volume um underscore. Let's actually volume not underscore max. And then let's duplicate this property and we'll rename the new one volume min. And then what we can do is we can take the volume min input and the volume max input. uh, let's actually make them both knobs just to make that a little bit easier to look at. They take up so little space. Well, let's put min above max. That was a confusing sentence. And then we want random float value. Okay. And then what we'll do is we will call this on play. Now here's another way you can see that this is not an execution. It is data, because we reference that data in other parts of the graph. And both of these will happen basically at the same time because the trigger values will be the same. For the min, we want this to be our min value, and the max be our max value, and then we're going to have the value output go to this. And now we can provide um, a random range. I don't know. We can go real quiet here. And Oh, hey, Eric, you're in the chat. Are you still in the chat? If Eric, if you're still in the chat, I I have unset my my monitor, my analyzer, hover analyzer. You remember how to turn that back on? Anyway, so now we have this as an input. Let's also add a pitch adjustment. So we'll do the same thing. Let's create a new float value and we'll call it pitch min. And we'll duplicate that and pitch max. And for pitch min, let's select that. And for the default value, let's go 0.95. We're going to want to give it sensible ranges because we want this to be a reusable MetaSound. And for pitch max, we'll go 1.2. So, oh, whoops. If I'm going to get rid of these this range limit, so I'm going to just undo this and undo this. Just get rid of these clamp defaults off. I don't want a widget. That's fine. We'll get rid of the clamp default and widget, and we're good. Fine there. Some base and spread. Yeah, yeah. The thing about base and spread is it assumes a it assumes a symmetrical, like the range is symmetrical, and that is the case in dB, in decibels, but in linear gain it is not symmetrical, right? Half down, half up is not the same, right? So I think it's important to acknowledge asymmetry when you're talking about random ranges. um but yeah, anyway, so let's do this, and we're gonna have the pitch min and pitch max be multipliers. We're gonna call them multipliers for now. So this is something that's useful in your units. You can add in the descriptor if you want, like what is the unit, or you can add it to the name itself, because there are different units for pitch. There's different units um, for gain, and so in this case, I want multiplier. So playback speed. In fact, we could even call it speed, like playback speed. We could do like playback or pitch speed min, something like that. So people know it's like a playback factor. Pitch speed max. Anyway, we're gonna do something very similar. We want on the play. We're gonna do a random float range. We're gonna copy this. I'm gonna paste it up here, or maybe I'll paste it down here. That's fine. And then we're gonna drag the pitch min to the min, the max to the max. And then we're going to convert this to semitones, because the pitch shift in the wave players units are semitones. You can actually, if you hover over this, you can see it's in semitones. So we need to go from a multiplier to a semitone. So we need to go, we want this frequency multiplier to semitone conversion node. And there we go. And now we have pitch adjustment and volume adjustment. And we could adjust this to allow, if you want like it to go over, if you want the range to go over some value, if you clamp value. So we can go over 100, like over 0. If we want it to be like some wide range there. And we could check our pitch is working by like giving it some really low, some really high value ranges. There we go. We got like piercing. Anyway, what you want is to set them in sensible ranges. I will do. Oh, that was a weird one. Why did I do that one? 25. Let's do 0.95. 958, 95. Okay, so now we have our MSS random basic. And I close it out. I'm going to go back to our random basic. And then what I want is I'm going to right click on it. And you'll see an option down here at the bottom to create preset. You can adjust where this exists in the settings. We looked at the preferences, editor preferences. By default, it's down here at the bottom. Create preset. And let's just make a new folder for our presets. We'll just go presets. And then let's go random basic. And then we'll say ren. And let's load this up with the actual ren. So when we double click, we'll see this graph that we cannot edit. We cannot edit this graph. But what we can do is we can alter the input. If we select our sound waves, we can say override inherited default. And this we're not going to change this out, but we are going to have this clicked on, and that will have our ren. And this will just give us the actual ren. So if someone changes the parent, the parent graph, our random basic, then this will stay the same. And if we're happy with the pitch ranges and volume ranges, actually let's adjust this. I'm gonna override the default for the min, and I'm gonna go 0.707, which is, oh wait, this is decibels, isn't it? That was my units, decibels. Was it decibels? Yeah. Let's go -3. Oh, I'm clamped. Wait. Was it just viewing it as decibels? Okay. I want it to actually be decibels. Where is this? Okay, if we go to our original one, we can just double click on this and it'll open up our parent. And here's what we'll do is we'll change this. I'm going to get rid of these knobs. Yeah, because it's oh, here it is. Output linear. There we go. Let's unclick output linear. Because I'm doing I need to do a conversion. Here we go. This is the issue. So we want decibels as the input type. And so I need to convert the input, let's convert the random decibel range, decibel to linear gain. So we'll do our own conversion here. It was doing the conversion on the knob, and I wanted to do it in our graph. That way, our values here can actually be. We don't want to clamp. Actually, we don't want to clamp. I'm not clamping. Cool. We don't want to clamp the defaults there. And then our min can be -3 dB. And our max, we don't want to clamp that. This will be +3 dB. Cool. And now we have our ren preset. These values I think are useful, so I'm just going to make them the default values anyway. Go boop. -3 for min. There we go. Okay, so we've got the ren. Let's make another one, and we're going to call it hawk. And so now the procedure here is actually really simple. We're not creating a new graph. We're just repopulating the assets. Right? There you go. And now we have a hawk instead. very similar variations there. And then every time we want some basic random type, you know, I don't remember what the next one is. Let's do swallow. There we go. Our birds, our bird trifecta, the three birds. We just swap out the sound waves with the ones we want. In this case, our swallow calls. Boom. So I think what's you know if we're talking about workflows, that presets our expected workflows. You're not, if you look at a typical a game, there's really only a handful of audio behaviors. Like you're probably looking at like maybe half a dozen, maybe 10 or a dozen max that fit 95% of your use cases. And then, and this one that I just made, it fits like 50% of your use cases. So, so what's powerful there is that you're not expected to work in the graph all the time. You're not expected to make a new graph for every sound. You just reuse the same behavioral structures over and over again. And yeah, and so then here you can see how quickly this could be even scripted, right? This is something that we've talked about on the live stream. Eric's talked about on the live stream. Creating tools and utilities to help script this sort of stuff and make it even faster. So it's actually pretty quick to work in MetaSounds once you've created those structures. The nice thing is you can go back in and make adjustments to the parent graph. If you're like, oh, I need to make some changes on how this works. It could be something like, let's say, oh, we want to support stereo wave player, which is pretty significant change. So we can adjust this to be stereo, and actually, we'll duplicate this and multiply both our channels. We'll just sort of like swap out. I'm gonna hold Control and grab this pin, and then just move it. I'm gonna hold Control, grab this pin, and move it. Same Control, drag. There we go. And now I've like done a little. It's like a little operation. I've done a little operations there, and then yeah, we want to make sure that we're little MetaSound surgery. And now, if our sound assets support stereo, then they will work. And if they're mono assets that we feed into the stereo wave player, it'll just output mono for both channels. So it does a simple upmix. And now if we go to our Hawk or any of these others, we can see it's got a stereo output now. So we've like modified in one operation, we've effectively modified 4 different graphs because 3 of them were based off of the first one. Okay. How are we on time? I think we're a little bit I think we're way behind actually. Who's still in it with me? I feel like maybe we should maybe we should split this up into a second part. Let's check our little checklist here and just see where we're at. All right. Let's go back to our plan for today. Okay, we talked about preparing the editor for audio work. We talked about what is a MetaSound. We've created a MetaSound. We talked about the data rate in MetaSounds. We've made a basic one shot. We also did the concatenation thing. We have talked about one shots. We have talked about sources and presets. We didn't cover patches yet. We haven't talked about pages. I want to talk about pages. Um, and I think, yeah, let's go. Let's do. Yeah, still here. Cool. Still hanging in. I know this is a lot of info. And like I said, if y'all got to bow out, it's okay. Let's we're pretty close here, so let's get through the rest of this. And yeah, there's some stuff I want to cover. So let's get through the rest of this, and we're so close to the end. So let's dig in. Yeah. So let's switch. This is so cool. Oh, yeah. Yep, understood, Karu. Hopefully you'll get to check in the recording later on. Like I said, this is recorded. So if you need to wrap, bring it in. Yeah. Yeah, Eric, I don't know. It's weird, right? It's a bummer. Okay. Let's switch back. And let it us I want to talk about pages, right? Pages and patches. So let's do a new MetaSound source. MSS random advanced. We'll just this is the name, but we'll just use it. And let's make it a stereo MetaSound. Let's go to MetaSound properties and select the stereo output format. We know this is going to be a one shot. And what we want is we want the behavior of our original MetaSound or basic MetaSound, but we want to plus it up. So let's make our random basic MetaSound referenceable, right? So let's open up the random basic at the same time. We got them both tabbed up here. And under the MetaSound properties of our random basic, go down to access flags and find referenceable. And then save it. And now if we go to our random advanced graph, if we right click and type in random basic, we will see the MSS random basic graph show up. And so this is our random basic graph. Hey Ivan, I'm glad it's useful. Yes, I prefer it over sound cues also. So now we've got some wrapped behavior. And I like the on play up above. It sort of organized things by like alphabetical organization. So let's go back to our random basic, and we'll see a sort order. And this is top to bottom is lowest value to highest value. So uh, I want my sound waves to be the next one in line. I want the volume min to be 2. We'll make it the next one in line. I could make the volume max the next one down. I already did that one. And then we'll go pitch min. I'm going to make it 4. And then pitch max, I'm going to make it 5th or fifth element, 5th index. And now you can see they're reordered in a way that I prefer. So if we were to just plug this in, whoops, we were just plug it in exactly the same. Actually we could have input, just make these inputs. We did. Let's get rid of the knobs. No clamp. Just get rid of those. I'm just hitting this reset thing just to get rid of the like modified property look. Boop, boop. So I just want them in exactly the same. Boop, boop, boop. So this is basically what our preset looks like, right? It's just this wrapped around. But we can do interesting stuff. Oh wait, what's the question? For a basic sound trigger, how do MetaSounds compare in resource usage versus sound cues? Well, yeah, that's sound cues. The logic in sound cues um, are done on the audio thread. The logic in MetaSounds are done on an asynchronous audio, like async task that is feeding into the audio render thread. So they're on different threads. Um, and sound cues are not sample accurate and MetaSounds are. Let me say this: sound cues are to be replaced. Like the fantasy is to move sound cues into a plugin that gets disabled by default. So sound cues are, you know, are. I would not expect anyone starting a project now to use sound cues. The only reason you should be using sound cues is if you have a UE4 project that you've just updated. Like Fortnite uses sound cues because Fortnite was made before Unreal 4, right? Like it's like a 15-year-old code base. The project is ancient. So there's no reason to use sound cues except for some very weird outliers. So sound cues are legacy. They should be considered legacy, yeah. But MetaSounds compile on uh, their compilation takes resources, uh, so they're more expensive in some ways, but not expensive in other ways. So it's just different, yeah. The variables and inputs are so all remember data rate is, so this is the question here is like phrased as like uh like a Mythbusters question. Plausible. Um they're not faster or slower. Yeah, they're the same. Inside the graph they're the same. 100 times a second. But inputs can feed data from the game thread, which is probably not 100 times a second. It's probably like 60 times a second or something like that. So, so that might be some confusion there. Yeah, it's I they're the same. Inputs and variables are the same as node outputs, right? They all get updated at the same rate, and they're all updating all the time. That's, I think, really when I play something here, you know, this input is getting read 100 times a second. The sound wave asset array is getting read 100 times a second. This float value is getting read 100 times a second. It's not changing. The value is not changing. Um, but it could be, right? But that's what's happening. If we look at this, this value is getting converted into linear gain 100 times a second, but there's probably something thing in here that's like checking to make sure it's changed. If the value hasn't changed, it's probably going to try to, as like an optimization, it's probably going to not do the process. Like that's a good practice if you're coding your own MetaSound nodes, is to say, okay, well, I want to do this function, I want to do this process, but I don't want to change the output value unless the input value has also changed. So, so there'll be like a check on the input, but it's a stream, it's a data stream, and this output value is it doesn't update at a higher or lower rate than variables or inputs or anything else that's referenced to the graph. So, yeah, so I hope that helps. Mythbuster stream sounds fun. Oh, yeah. Yeah, they're legacy. Yeah, I would not. So I have been I've been like the tech lead on a bunch of the sample projects. And all of them I've had to work with contractors who didn't always do what I asked or requested. But I have tried to, especially on things like Project Lyra, present the best practice of the time. And you will not see a sound cue in any of my projects. You will not see one. Yeah, so yeah, the difference between inputs and variables is that variables are not accessible externally, right? So yeah, inputs if you're doing anything special in inputs. Anyway, let's make this a little bit more interesting. Okay, let's add some tonal variation. We're gonna add some processors. We're gonna have a little fun. But let's let's add a biquad filter. I think I did this in one of the other streams. Let's do this. Boop. We're gonna have I copy and paste them. We have two biquad filters. One is going to be a notch filter. One is going to be a actually let's do two notches. Actually let's do one we'll do bandpass and a notch. And let's put the frequency let's do 1000. Just sort of put the band in the middle. I want to see what this bandpass looks like. Yeah, that's fine. Actually, let's create a patch that does this. What I'm gonna do is I'm gonna cut those. So let's create a patch. We haven't created a patch yet. I want to create a patch. Do patch is patches. Right click, go to audio, go to MetaSound patch, and we'll call it MSP. Yeah. And we'll call it stereo spectral variations. That's what we'll call it. Boom. Save it. We'll open it up. Now let's paste our filters, and we're actually going to paste two pairs of them. So we're going to paste one pair and two pair like that. Actually, we could make them, maybe we could stagger them like this. That might be interesting. Okay. Now what we need is a left input. So let's drag off the biquad filter in here, left, and go, we'll call it audio. Actually, let's do in audio left. And then on the staggered one, let's put it like that, I guess. On the staggered one, again, the notch filter, graph input, and then we'll call it in audio right. Cool. Now we'll drag in audio left to the bandpass, and then right to the other right bandpass. We're basically making, on the left side is our left processor, left side processor. On right, we're a right side processor. And then our output, what we're going to do is we're going to add these. We're going to sum them together. Add. So we're going to add the audio together, and then we're going to output, and we're going to call it out audio left. And then the same thing, we're going to add these two together. I'm going to make it out audio right. Okay, so we got our inputs and our outputs. And then what we're going to do is let's add a trigger input. And we'll go trigger, we'll just call it trigger. So a new input, we'll call it trigger. We'll, with the input selected, we'll select the type, and we'll scroll down to trigger. It's alphabetical. So trigger type. And kind of like what we did is we'll make these, the audio sort order to be a higher value. So I'm just going to make them 5 each. Just make them both 5. Put whatever you want, whatever number you want in there. But the lower number, trigger, is at 0. And so I know the trigger is going to appear higher up on the sort order. I wish that was reflected here, but it's not. And then what we're going to do is on this trigger, we're going to randomize all of these values. So we want to randomize the frequency, but we want to favor lower frequencies. Remember, frequency is logarithmic value. So the question is, Lyra is the last sample project for best audio workflow practices. I mean, Electric Dreams. So Lyra is the most complete sample example of best practices. Like you could look at Electric Dreams, which is newer, 5.2, I think. And Electric Dreams is not a complete project, right? It's just like a graphics and like procedural generation, a procedural PCG demo. So it doesn't deal with things like mixing. A lot of stuff was pulled out that was interesting, that was related to the Rivian, that sort of stuff. So it's not like there aren't actually a lot of complete projects that you have sample projects of. Yeah. So, but Lyra, I think is a pretty good one. But it is old. I understand that. Okay, where was I? Right, we want to favor lower frequencies. So let's have a conversion node to linear to log frequency node, and we'll actually do 4 of these, because we're going to randomize all of these frequencies. We want them to be different for all of them. And we could also randomize the bandwidth. So we're going to want 2. Actually, delete this trigger node for now. We keep it in our inputs, but we don't need it on the graph right now. We want random float. We want 4 of these, or 2 of these for each filter, because we're going to randomize the frequency and we're going to randomize the bandwidth. So I'm just pasting them out. All right. So for the this is fine. We can just plug this in and plug this in, and we're good. And then we can take this and we could do like a 0.1 to 2 or something like that, and make that the bandwidth. You know, wherever it makes sense to organize this stuff. And so we'll do the same thing, because what we want is different values. We kind of want it to keep changing. We want to keep evolving this these variations. I'll keep doing that. Yep. Boop. How are we looking? Okay, and then all of these will be triggered by our trigger here. And you can just copy that node and you'll get a reference to the trigger input for each of the nexts. And basically what this means is that we can trigger a change in the spectral qualities here to give us a different spectral flavor for this. And you'll see if we look at the sound properties that it's already set to reference patch properties. It's already set to referenceable. And let's give it a fancy display name. We'll call it spectral variations stereo in parentheses. So we can give it a nice fancy name. We can say band, pass, and notch filters randomly flavor the input spectrum. There we go, something like that. Yeah, you could have fun with it. So if we right click and we call spectral variations, see our nice fancy name shows up. And we have a little processor. And now we can hook this up. And on play, trigger those random values. Do we have anything loaded up? We have our rens. So this is adding some filter variation, but you can adjust the bandwidth ranges, which I did on only one of them, apparently. Let's do, we could do like, let's do 4. So, you know, these could be parameterized, right? So you could do like, bandwidth min. Bandwidth max. And then just reference those for all the rest of them. And this allows you to not only tune it later on, but make them consistent, make sure they're consistent across all of the implementations. And if we look at our random advanced, now we have our of course I want these to let's give them sort order of 10, leaving a big huge gap just in case I want to add something else. Maybe I'll make max 11. There we go. And yeah, now they're nicely at the bottom. So these will just be adding some subtle variation. Like if we pass noise through these, we select noise generator, and we just pass noise through these just to, you can kind of hear. Let's make the max 4. You kind of hear the stereo sort of variation and some spectral variation between the two channels. So that's it's a very subtle effect, but it could be useful, especially if you have, very similar variations. Let's add a we'll add amplitude modulating, a continuous amplitude modulating effect. So let's add a what do we want to add? I want to add uh, let's add audio to float to audio. We're gonna do that. We'll make it additive. It's a little dangerous adding directly to your mm, uh, and no, let's do a multiply. Just let's do multiply by float. Yeah, we'll do multiply. The reason so you can add directly. It's just maybe it's not right for this kind of workshop. We'll add some low frequency noise, and we'll have a min value of 0.25 and a max value of, let's just do 2, and put the output into there. So and we could increase the frequency. Let's do like maybe like 15 could be interesting. Just need to be careful because you could be adding some amplitude texture that maybe you don't want. We could also make it. Let's go with 10 as a sort of compromise, and then we could also rein in the step limit. Basically, what this is doing is it's just generating random low frequency noise, and it's just sort of interpolating between every 10 times a second. It's generating some new value that is up or down, whatever our step limit is, and then it's interpolating to that new value. So you can hear some changes in the amplitude as it goes through. Uh, so the question is, are these in buses? And I would say, unfortunately, the buses are there's no MetaSounds in buses, but you can have a bus. There is a bus reader, so you can read in from an audio bus, and there is a bus writer, so you can do processing on an audio bus with a MetaSound, but it does incur latency, and the MetaSound is a source right now. It has to be played, so it's not just a pure effect. But you could process data on a bus, feed it back into the bus while this MetaSound is playing. Or you could just play the MetaSound as the output of the process bus, like a source bus. But it will be one callback buffer latent because buses are processed after sources. So in order for that data to be available to sources, it's going to be the previous buffer data. Um, and then the other thing that we can do is very similar, is add ADSR. So that's like a classic one. So we'll add some more amplitude modulation. And so we'll just add another set of multipliers. And we'll add we'll do a 80 we'll do an yeah, we'll do an ADSR. We'll float ADSR envelope. On play, we will do a trigger. And then what we can do, it's a little bit sneaky, but what we want is we want to know the duration of the selected audio, but this audio selection is happening inside this sound. So what we need is to get the duration of the selected sound so that we can add a release tail. So let's go back to our basic MetaSound. And then what we'll do is when we've selected a wave asset, from here, we want the wave asset info, get wave info. And you see one of the things is duration. Let's make that an output, a graph output. There we go. So now if we look at our advanced, we have duration listed as data for our output. And so what we can do is we can have a random attack time and a random release time. Let's make the sustain 1, and we'll make the decay 0. Okay. And so what we'll be doing here is we'll be adding in some possible fade in and some possible fade out. But we want it to be random. So what we're gonna do is we're gonna get a random time, and we'll do this. We'll just do this to sort of clean that up a little bit. So we get random time, and we want input. This will be we'll do fade in time min. And we'll just get rid of the knob just to make it cleaner. And then we'll want fade in time max. Okay, and we'll just bring this up here. Just give me more space. And we're going to basically want to do the same thing, but for the release time. So we'll copy that. We want that for the release time. But our what we want is actually, now that I think about it, we want this value to be within this range. So we want to here's what we're gonna do. We're gonna take our fade out time, graph input, fade out time min. We're going to do fade out time max, fade out time max. Okay, and then what we're gonna do is, so if you're not familiar with ADSRs, ADSR is a type of envelope, attack, decay, sustain, release. And what happens is the attack, decay, and release are all time values, and sustain is a level value or volume or gain or whatever. And so it's a type of modulation, that is typical of sound sources. Like a lot of sound sources will have some kind of onset, some sound that is usually like a abrupt onset or transient, and then there'll be some sustained level or no sustained level, and then some release time. Like if you pluck a guitar, you might have like a very fast attack, but the release is very, very slow, right? Um, if you have a trumpet, you might have a abrupt attack, but maybe not as abrupt as your guitar. And then there'll be it'll like the decay might be real short, and then you'll have some sort of sustain, and then when the instrument is done, it might have a pretty fast release, but not a zero fast release, not an instantaneous release, right? So that's that's the idea behind ADSR. We're going to use it as a fade in, fade out. So the attack time is our fade in time. Our release time is our fade out time, and the we're gonna ignore decay and sustain. We're just gonna have we're zero out decay. We're gonna have sustain be as the maximum value, 100%. And then what we're gonna do is we're gonna randomize the fade in, fade out, but we want the release to happen. Um, the release has to be triggered. So we want the release to be triggered in advance of our fade out. And so we need to take the um, the random fade out time, and we need to take our duration of our sound and minus the random fade out time. And that's going to give us the time in which we have to delay before. Remember our trigger delay? We're going to use a trigger delay to trigger the release. So if let's add our trigger delay. Trigger delay. Let me switch to water here. Hi, Ilya. I feel like we're probably not going to get to that in this. The question is implementation question. We'll probably not get to that right now, but sources can be played like any other source. Maybe we'll do another one where we focus on implementation. But as I kind of said at the beginning, I feel like we're going to be mostly focused on just the MetaSound and getting into the MetaSounds. Most of the aside from passing parameters in or getting parameters out of the MetaSound, most of the MetaSound usage right now is still going to be like any other sound source, and so you're gonna use it just like you would a sound cue in place of a sound cue on all the same functions. And even the sound cue, the way the sound cue inputs works the same for MetaSounds. They use the same input interface, the same parameter audio parameter interface, and that's by design because there was already a bunch of stuff that allowed you to pass data into a sound cue that existed, and we just wanted to be able to swap out the MetaSound underneath the sound cue and have it still work the same way. So yeah, we're I feel like because the length of this has gone long enough that we are not going to get into that. And even this is kind of getting a little crazy here. Uh, but yeah, so chances are no, that's not gonna happen during this time. Let me get the duration. You subtract, and then all we want to do is we want to make sure that this doesn't go into negative values, right? That's so. Thanks for your question, Ilya. I we you know we'll see. Maybe I'll do another one where we go more. This definitely was longer than I expected. I expected it to be like 2 hours. But yeah, yeah. Sorry about that. All right, so we just want to make sure it doesn't go into negative values. Um, and let's. So we want a we'll go to float. We need a math operation called max. Um, and from float we can call max float, and then we'll convert this back to time and pass that in. And this max float, what this does is it basically picks the biggest of two values. It picks the biggest of two values. So if our input is under 0, then it'll pick 0, and the delay time will not be nothing. It'll fade. It'll fade immediately. Uh, uh, and yeah. Actually, let's instead of fading immediately, let's add the fade in time. We're going to add that to it. So it won't fade out until it's done fading in. And it's tough cookies if that's gone over time. All right. So our default fade min is 0. That's fine. Let's do a default of like 2 for our max, and then likewise 0.2 on our min. And now we've got some extra variation. And it might be not noticeable on these particular assets, you know? Again, if I were to sub in noise, let's see, are we getting good? Pretty long fade times. Let me try 0 fade time, fade in. And let's make sure we always have some kind of fade out. Let's go like that. Let's see if that's getting... That's a little better. Let's give our let's give our release curve a little bit of a concave slope. So we'll go. Let's do 0.5. That might be maybe a little too abrupt, but I just want to. Yeah, it's a little bit better. Let's go 0.3. I want to try 0.3 on this. That's not bad. Maybe we'll stick to 0.5 for now. Anyway, so yeah, so again, this is like this noise should sound the same every single time, and we're putting a lot of amplitude and spectral variation into this. Okay, let's hook this back up. Now we have like a more advanced graph going on here. A lot going on. We've got processing. We've got amplitude modulation happening. Low frequency noise. There's quite a bit going on. And what we want to do is we want to simplify this for our lower end platforms. Maybe we decide, hey, this is actually fine for PC, it's fine for consoles, but maybe on our mobile platforms, this is a little excessive. So this is where we want to get into pages. So let's go back to our project settings. And if you go to the engine audio, you'll see, scroll down. Oh, did I, or is it in, sorry, in plugin, is it in MetaSound plugin? Misremembering where it is. Ah, yeah, it is here. So if you go to plugins and then MetaSounds, you can see the pages. And so what we want is we want to add a new page. And let's see. I think we just need a new page settings. So if we go page settings and we just add one, let's call this one low tier. And we're going to add um, mobile to this set. And yeah, mobile includes all of these. So Vision, tvOS, iOS, Android. Let's say that's fine. So we'll have default, and then we'll have mobile pages. And with the page, when we do that, let's close this. Go back to our advanced, random advanced. Open it up again, and you should now see a pages tab on your details, next to your details. And the pages tab, now we can add basically what pages allows us to do is it allows us to do two main optimizations to the MetaSound. One is a memory-oriented optimization. We can go to our things like our sound waves asset list, and we can create alternative versions of this content based on our preference here. So here I have example. I've got 9 variations of this Ren sound, and maybe 2 or 3 is fine for our mobile platforms, right? So let's add to our low tier set, and it's going to copy it over. And then I'm going to select, I could play between these. Okay, maybe I like that one, I like that one. And yeah, this is good enough. And then everything after this we'll delete, I just want these 3. And this way I could pick what I think are maybe the 3 best variations. So what this means is that on our low tier platforms, which includes our mobile platforms, these are the only 3 variations that are going to get cooked out. For every other platform, we'll have 9 variations. But we can go the extra mile. We can say, you know what? We don't need all this advanced variation stuff for our mobile platforms. It's fine if we just use our basic. Remember our basic, right? Our basic, random basic. So let's create also a CPU optimization by creating a distinct graph. So if you go to the pages tab, you can add a new page graph for the low tier page graph. And now our pages tab allows us to navigate between the pages. You can see it was very fast, but you can see now in the lower left-hand corner, it says graph page low tier. We're actually looking at the new low tier page. We can switch back to default by clicking default, back to low tier by clicking low tier. They look the same because they're copies of each other. But for low tier, now we want to get rid of all this crazy advanced stuff. Just get rid of it. We're not going to use it. We're just going to ignore it. I want to get rid of all of this. Actually, you know what? Let's get rid of everything but this low frequency noise. I think the low frequency noise is pretty cheap. So we'll just keep that part in. Okay. And maybe I'll go so far as to say, let's have low frequency noise for each channel. Because I think that is something we can afford on our low tier platforms. And so let's have our multiply audio by float node, and we'll just go copy and paste. And we'll do the same to both of them. And now we have, it's basically our random basic with our 3 variations instead of 9, and some really cheap amplitude modulation on the channels. And that's fine. And we could, if we wanted to, we could maybe adjust some of these values if we feel like it needs to maybe get plussed up in a different way. And now we can, if we can swap back to our default, we get the big, huge, cool graph, default graph. And then on our mobile platforms, we'll have this version instead play. Yeah, that's something I haven't gotten to, but yes, that is why. So Eric mentioned something that's really important. On your parent graphs, once you're done authoring, you'll want to get rid of any wave asset references. It will make sure that stuff doesn't get cooked out. But it's something that you kind of want to do when you feel like you're like, oh, I'm done auditioning these, because then we can go back and create presets based off of, just like we've done before. Let's say this is for our what do I have? Did I not? Let's just say footstep concrete. Yeah, and then maybe not a great example of like footstep design, but yeah, we can override this, and let's just trash both of these right now. And for the cement, we'll do all the variations for the defaults, and then we'll just pick my favorite two footsteps for the low tier. And anyway, yeah. And then you can audition. If you want to audition, you can change the audition settings. But yeah, I think that's pretty good optimization. Wondering what's the best practice for attenuation spatialization, especially in VR. I assume that was an R with a end parentheses and not a pirate face. Yeah, I mean attenuation spatialization. I think you it depends. With VR, you may be using some platform specific spatialization stuff. So, that may affect what your how you implement the it's kind of like when you're talking about binaural and interaural time delays differences. HRTF models, like uh, they're all kind of different from each other. The way, at least all the ones I've seen, they kind of implement differently from one another. So I would say it depends on the spatializer you're using. There are some that we ship with. There's some basic ones that we ship. We have Google Resonance, and we have a native ITD, which is just the time delay between your two ears. And those are good starts. But yeah, I think it depends on what your spatializer is. I think binaural is really important for VR though. I think it's the place that you can appreciate it most because you have head tracking. Head tracking gives you a lot of really cool resolution to spatializing, realizing 3D sound. Yeah. Okay, yeah. So we did an advanced variation, we did optimization with pages. I think we're looking good on our checklist here. Let's just review it here. Yeah, yeah. Maybe I'll do a music stream separate from this. I think I feel like that's a little involved. So I would just say let's wrap it up here with the role of MetaSounds in audio production. I think it depends on your audio team a lot. Eric's in the chat here, um, and the the audio team at Epic is big enough where you can have people who don't really get into MetaSounds much at all. Some people who dig into them deeply. You have, it's sort of a mix actually. It depends on the designer, and it depends, I think, somewhat on the policy of the organization and the team. Because I think Epic, maybe for better or worse, we allow sound designers to get into MetaSounds and dig in and do cool things. A lot of our sound designers are very technically capable, but there are some folks who don't really get deep into MetaSounds, and maybe they sort of rely on a tech designer to do a lot of the work. I think what you've seen here when we talk about presets, there is something a little bit more technical about building the graph, but then the preset is like easy, right? It's easy peasy. You're just setting some parameters, you're setting the new sounds that you want on there. And so I think that is something you should expect. If you are, like for example, let's say if you're on a really small team or an indie project that's just really scrappy, you could be the only audio person, and maybe you're the person in MetaSounds, but you're creating presets that allow maybe some of the other designers to help with linking up content. They don't have to get in the graph, they don't have to touch it, and you can just sort of be the purveyor of the MetaSound graph, and then or you could get, there's other, if you're like on a company where using contractors, could be a situation where the contractors are fencing assets to you and you're just receiving sounds. A lot of special projects that I worked on, a lot of sample projects that I worked on, that was the case. Project Lyra, well, not Project Lyra, but like Project, sorry, stop. I can't do the Valley of the Ancient project is a great example where I was doing the MetaSound stuff, and Sweet Justice and Rebound were sending me assets to implement into them. So it could be something like that. It depends on your team structure to a great degree. It depends on your human resources, um, but uh, but there is a sort of technical aspect of working in the graph. But MetaSounds don't exclude people who aren't technical. Like MetaSounds can include people through presets, and you'll see. Eric. I think at sometime real soon here, Eric and I will have some presentation. I hope we'll do something. Actually, Eric posted a cool video recently that shows some of the stuff that will make working in MetaSounds even less technical for, or more accessible for people who aren't technical, so-called technical, and uh, or who just don't want to get into MetaSounds for some reason. I think they're fun, but yeah, there's ways to sort of visualize presets. We haven't. I wasn't sure if I was going to get in preset widgets at all. But yeah, that's something that your team can work on as well. So a lot of this, a lot of the UX stuff is newer because we've had time to focus on that stuff. A lot of foundational stuff had to come before it. But yeah, I hope this was useful. We got 20 stragglers hanging in there for the long haul. Really appreciate it. Are there any questions? I kind of want to wrap it up. I think everyone else is kind of feeling that as well. Uh, yeah, 2 to 3x cheaper. I don't know what that means. Combos. Any questions lingering in the chat? Awesome. Yeah, thanks for joining everyone. I really appreciate y'all. I hope this has been helpful. Feel free to ask questions in like the comments and stuff like that. But yeah, I hope everyone has a really good new year. And yeah, hang in there, everyone. World is crazy, but you can still do things, still work on the things in front of you. All right. Thanks everyone. Talk to you later. Bye.